This morning, a state of emergency across California as massive amounts of rain drench the West. It is day 3 of a relentless storm that has now turned deadly.
At 6:47 a.m., the radio crackled with urgency. Code 3 water rescue, Cannon Beach, Oregon. The sky was still grey, the shoreline quiet, and most people were just beginning their morning routines. But out in the freezing Pacific, 2 people were already struggling in the water, while a third clung desperately to a jagged rock nearly 50 feet offshore. Waves crashed over his head every 20 seconds, each surge stronger than the last, each one threatening to pull him under for good. Firefighters rushed toward the shoreline, knowing they had only minutes before the ocean would take control completely. This was not a normal winter morning on the West Coast. The tide was rising fast, the swells were growing larger, and the ocean was behaving with a strange mechanical rhythm, relentless, precise, and unforgiving. From Oregon down to California, reports were already coming in of massive waves, flooded harbors, and dangerous surf conditions spreading along the coastline. Something powerful was moving across the Pacific, and coastal communities were beginning to realize that this was more than just rough weather. Stay with us as we break down the science, the risks, and the real-time updates step by step. And if you find this kind of clear and reliable information helpful, consider subscribing to the channel and turning on notifications so you can stay informed, stay prepared, and stay safe with every new update we share. By mid-morning, it was clear that the situation at Cannon Beach was not an isolated incident. Reports were coming in from across the entire West Coast, painting a much larger and more troubling picture. Along the Pacific shoreline, massive swells were slamming harbors, flooding waterfront streets, and forcing emergency crews into constant response mode. In Santa Barbara, seawater pushed into the harbor, submerging docks and parking areas that rarely see flooding. Farther north sections of Highway 1 near Monterey were shut down repeatedly as waves surged over the roadway, leaving behind debris, standing water, and damaged guardrails. In San Francisco Bay, breaking surf climbed to levels not seen in more than a decade, while in Seattle, parts of the waterfront were temporarily underwater as powerful swells rolled in with relentless force. Coastal communities watched the tide line creep closer to homes, businesses, and public infrastructure, unsure how far the ocean would advance next. The National Weather Service responded by issuing high surf warnings across much of the Pacific coastline, urging residents and visitors to stay away from beaches, rocks, and jetties. What began as a single rescue was now revealing a regional coastal emergency that was still unfolding. What makes this event especially dangerous is not just the height of the waves, but the way they move and the energy they carry. At first glance, many people see large waves and assume it is simply another winter storm. But along the West Coast, scientists and forecasters are noticing something unusual. These swells are arriving in long, powerful intervals that dramatically increase their impact on the shoreline. Instead of short, choppy waves that rise and fall quickly, these waves build slowly, travel farther, and surge deeper inland when they break. This longer wave period changes everything. Each swell carries energy that has been building for days across the open Pacific, and when it reaches shallow coastal waters, that energy compresses and intensifies. The result is a powerful surge that does not stop at the edge of the beach. Water rushes across sand over rocks and into areas that normally remain dry, catching people off guard within seconds. Lifeguards describe it as a silent threat because the ocean may appear calm between wave sets, only to unleash a sudden and overwhelming surge moments later. This is how sneaker waves form, unpredictable, fast, and capable of turning an ordinary beach visit into a life-threatening situation. To understand why these powerful waves are striking, the West Coast scientists are looking far beyond the shoreline, deep into the North Pacific Ocean. More than 2,000 miles offshore, massive low-pressure systems have been spinning across the winter ocean, forming enormous atmospheric engines that transfer energy directly into the water. These storms are not fast-moving systems that pass through in a day. They linger for days, sometimes stretching across hundreds of miles, pushing strong winds in a single steady direction across the ocean surface. This sustained wind creates what meteorologists call a long fetch, a wide corridor, where energy is continuously fed into the sea. At first, small waves form, but as the wind continues to blow hour after hour, those waves organize into long, powerful swell trains that begin traveling across the open Pacific. By the time they leave the storm system behind, they are no longer local wind waves. They are deep ocean swells, carrying the accumulated force of distant storms, moving steadily toward the coastline. When these swells finally reach shallow waters along California, Oregon, and Washington, their stored energy is released, transforming distant storm activity into the dangerous coastal surges, now threatening communities along the Pacific. Sure, the true danger of this event lies in the physics of long-period waves and how they behave as they approach the coastline. Most waves that people see at the beach are driven by local winds and arrive in short intervals, rising quickly and breaking with limited force. These waves lose energy fast and usually remain close to the shoreline, but the swells hitting the west coast during this event are fundamentally different. They have traveled across the deep Pacific for days, building strength and organizing into long, powerful wave sets that carry far more energy than typical surf. As these long-period swells enter shallow coastal waters, their speed decreases, but the energy they carry does not disappear. Instead, it compresses. The wave grows taller, the crest steepens, and the surge becomes more aggressive as it moves toward land. When it finally breaks, the water does not simply collapse onto the beach. It rushes forward with momentum, pushing across sand, rocks, and coastal structures with surprising reach and force. This is why people standing well above the normal tide line can suddenly find themselves surrounded by water within seconds, with little time to react or escape. Behind every warning issued during this event is a network of real-time data that scientists and forecasters rely on to understand what the ocean is doing. Dozens of deep water buoys positioned off the Pacific coast continuously measure wave height, wave period, and direction, transmitting updates every few minutes. These floating instruments rise and fall with the ocean's surface, capturing precise motion data that reveals how much energy is moving through the water. During this event, multiple buoys off California, Oregon, and Washington reported significant wave heights well above normal winter conditions, along with unusually long wave periods that immediately triggered concern among forecasters. But buoys are only one part of the monitoring system. Weather satellites track the development and movement of North Pacific storm systems, mapping wind fields and pressure patterns that generate long-period swells. Coastal radar stations measure how waves approach the shoreline, while computer forecast models combine all this information to predict when and where the strongest surges will arrive. At the National Weather Service, meteorologists analyze these datasets around the clock, issuing high surf warnings only when the evidence clearly shows that conditions pose a real and immediate threat to coastal communities and public Baltic safety. As the powerful swells continue to strike the west coast, the real-world damage is becoming impossible to ignore. Harbours that normally operate with predictable winter conditions are now struggling to keep boats secure as repeated wave surges slam into docks and outer jetties. In Monterey and Santa Cruz, harbour crews have worked around the clock trying to stabilise vessels and prevent mooring lines from snapping under constant pressure. Some fishermen have already pulled their boats completely out of the water, choosing safety over risking equipment and livelihoods in conditions they describe as the worst in many years. Along California's iconic Coastal Highway, sections of the road have turned into danger zones. Waves surge over the pavement during high tide, leaving behind debris, damaged guardrails, and standing water that makes travel extremely risky. Road crews continue emergency repairs, but each new wave set brings fresh destruction. Farther north in Washington, the situation is even more complex, as heavy rainfall combines with high surf to push water inland from both the ocean and overflowing rivers. Low-lying neighborhoods face evacuation orders, while families gather essential belongings, unsure when it will be safe to return to their homes and coastal communities. As the immediate danger unfolds along the west coast, scientists and coastal researchers are beginning to focus on a deeper and more complex question. Why does this event feel different from typical winter surf? Powerful waves are not new to. The Pacific coastline and long-period swells have been recorded for decades. However, what stands out in this situation is the persistence, the scale, and the wide geographic impact occurring at the same time. Storm systems in the North Pacific have remained active longer than usual, and the wave energy they generated has continued reaching the coastline for days without significant weakening. Researchers are now comparing this event to historical high surf periods, including the powerful winters of the early 1980s and late 1990s, when strong El Niño patterns drove extreme coastal damage across California and the Pacific Northwest. But the current ocean and atmospheric pattern does not perfectly match those earlier events. The climate system appears more neutral, making it harder to explain the intensity using traditional seasonal cycles alone. This uncertainty is what concerns scientists most, because it suggests that the forces shaping extreme coastal events may be evolving in ways that are not yet fully understood. As scientists continue analyzing this powerful wave event, many are looking at the broader role of changing ocean and atmospheric conditions. Warmer ocean temperatures can store more energy, and that extra energy has the potential to fuel stronger and more persistent storm systems across the North Pacific. When storms last longer and winds remain steady over large areas of open water, the waves they generate can travel farther and arrive at the coastline with greater force. Over time, even small shifts in average ocean temperature or wind patterns can significantly increase the probability of extreme high surf events. Changes in the jet stream and seasonal pressure systems may also be influencing how storms form and move across the Pacific. Some climate models suggest that atmospheric patterns are becoming more unstable, allowing storms to stall or intensify in ways that were less common in previous decades. This does not mean every extreme wave event is directly caused by climate change, but it does indicate that the environmental conditions supporting such events may be becoming more favorable. For coastal communities already dealing with erosion, rising sea levels, and aging infrastructure, the growing intensity of ocean-driven hazards is becoming an increasingly urgent challenge that demands long-term planning and adaptation. For now, the focus remains on safety as powerful swells continue to move toward the west coast. Forecast models show that storm systems in the North Pacific are gradually weakening, but the energy they have already released into the ocean will continue reaching the shoreline for several more days. High surf warnings remain in effect, and emergency officials are urging residents, tourists, and surfers to stay away from beaches, rocks, and jetties until conditions fully calm down. Even when the ocean appears quiet, long-period waves can arrive suddenly, pushing water far beyond the normal tide line and creating dangerous situations within seconds. Agencies continue to monitor wave activity, storm movement, and coastal conditions in real time, making adjustments to warnings as new data arrives. The message is simple but critical: respect the ocean and take every warning seriously. Events like this will happen again, and preparation will determine how safely communities respond. If you want to stay informed about major weather threats and coastal hazards, follow the channel for clear updates and responsible reporting that helps you stay prepared and aware every day.